Alright class, so we're going to be starting chapter 6 of 6.1. So 6.1 covers graphing lines given a point and a slope, as well as graphing lines given an equation. So let's go for some examples. The first one that we're going to look at is graphing a line given a point and a slope. So for this particular example, we have to graph a line that passes through the point negative 2, 2, and has a slope of 5 over 2. So the first thing we're going to do is plot the point that's given. So in this case, that point is negative 2, 2. So I'm just going to label my axes. And I'll plot the point, negative 2, 2. Just with regards to labeling the scale, you only need to label the scale if you're going up by a number other than 1. So I plot the point. And now I'm going to use the slope to plot two other points on the line, so I'll get a nice straight line. So in this case, the slope is given. It's 5 over 2. And back in chapter 5, I know the rise is 5, the run is 2. Okay, so what I'm going to do is apply the slope to plot two other points. And the way I'm going to do this is, from the point that's given, we know the rise is positive 5, so we're going to go up 5. Run is positive 2, so we'll go right 2. So that's another point on the line. Okay, I need to plot at least one more point, but I can't go any further up here because I have no space, so I'm going to go in the opposite direction. Now if I go in the opposite direction, instead of going up 5, I will go down 5. Instead of going right 2, I will go left 2. You connect this point to a nice straight line, extend it, arrows on both ends. And then what I'm going to do as well is label the line with its equation. So we know from chapter 5, equation of a line is y equals to mx plus b. To complete the equation, we need to know the slope and the y-intercept. In this case, the slope is given, it's 5 over 2. Y-intercept, we get it from the graph, it's right at 7. So your equation would be y equals to 5 over 2x plus 7. And I'll just label it beside the equation. And that's how we graph a line given a point and a slope. So next, we'll take a look at graphing a line given an equation. For this example, the equation that's given is y equals to negative 2x plus 3. And we're going to graph the line that's represented by this equation. So the first thing, we're going to plot the point that's given. Now in this case, we're only given the equation. And we know for the equation of a line, we're given the slope and the y-intercept. So the point that's given will be the y-intercept. So in this case, the y-intercept is 3. And I'll plot that on the graph. Label the axes. Y-intercept is 3. And then the rest is the same. So we're going to use the slope to plot two other points to make a nice straight line. The slope is negative 2. If we want to interpret as rise over 1 run, it will be negative 2 over 1. So your rise is negative 2. Your run is 1. And we're going to apply it to plot the other points. So this time from the y-intercept, rise is negative 2, down 2, run is 1, right 1. And then we're going to do this again. Down 2, right 1. You can plot more points, but you need at least 3. And the equation is given, so we'll just label it beside the line, y equals to negative 2x plus 3. And that's how you graph a line given an equation. So the only difference with this in the previous example is, the previous example you're given a point. This one, with the equation, the point that you're given will always be the y-intercept because that's part of the equation. So let's go for another example where we're graphing a line using given an equation. This time the equation is y equals to -3/2x. So the point that's given, we know it's the y-intercept, but there's nothing after the slope. If there's nothing after it, that means the y-intercept is just 0. Label the axes. Y-intercept is 0, so it's right at the origin. The slope, in this case, is -3/2. Your rise is -3. Your run is 2. You can always put the negative with the 2 instead of the 3, but just making sure that you're not putting the negative with both numbers. Otherwise, it's going to be a positive slope. So in this case, I put the negative with the rise. So to plot the other points, this time I'll go down 3 and then right 2. Rise is -3, so down 3. Run is +2, so right 2. Extend the line, arrows on both ends. Label it with the equation y equals to -3/2x. That's it for 6.1. So make sure for 6.1 we know how to graph line using given a point and a slope, as well as graphing line given an equation. Again, the only difference is for one of them you're given a point, and in the other one when you're given the equation, you have to find the point in the equation, which is always the y-intercept. So the assigned work for today is 6.1. Before you do that, on the back, you will see a little game. So for this game, you need to find a partner. Once you find your partner, what you need to do is you need to Google virtual dice. So let's say if I'm going first, I'm going to roll 3 times. So I'm going to get 3 different numbers. So let's just say I got 1, 2, and 3. Okay. So my equation for equation 1 will become y equals to 1/2x plus 3. After I get my equation, I'm going to graph it on the grid on the right. So y-intercept is 3, slope is 1/2, so rise is 1, run is 2. Make sure you extend the line because you're going to be looking at where your line crosses. So in this case, you're going to look at these invaders. So in this case, my line crossed these 3 types of invaders. So there's 2 of these ones, in which case I'll earn negative points, and 1 of these, which I'll get 6 points. So in total for equation 1, you get a total of -8 points. And then your partner takes his or her turn, and then I'll go again. I'll make 3 rows again. Just be mindful of the equation. For the second one, your slope will be negative. Third one, for the equation, your y-intercept will be negative. The fourth one, both your slope and y-intercept will be negative. So you get 4 different equations, 4 scores, total them up, and the one with the highest score will win. Okay, so this is a good practice of graphing lines given different types of equations. So play this, complete 6.1, and that'll be it for today. If you missed any part of the lesson, as usual, I will post the completed note online, as well as I'll post the link to the video as well. Okay, and that's it for today.